All right, good morning everybody. Welcome to our third webinar, this one for April. We're joined today by a number of members of the team who are going to be trying to answer your questions on the Q&A panel. So you should all be able to see now a Q&A panel. Please do try and post your questions there. We will do our best to answer those. We will do our best. As I said, we may get to some of them a little bit later. Last time around, so you're aware, we didn't get through all the Q&A, but we did try and make sure that we followed up with the Q&A questions and answered those afterwards. So the WebEx recordings from this webinar will be available, as will the slides and also the demo topologies that we're going to be showing. Okay, so this is what we're going to be covering today. We have our new April release. So we're going to spend some time just looking through the highlights of that and also showing you how you can do the quick upgrades. We're going to do that live. Tom is going to show you some of the Git integration capabilities and also what we have running in our Git repository. We've got a demo, a recording from Daniel. Daniel's actually not able to join us. He's actually in Australia, so hopefully fast asleep, but did a recording showing some of the work that he's actually doing with VIRL. Daniel is a Cisco engineer, so he's showing you some of the stuff that he does with his customers. I'm going to be showing you some of the integrations that we've now got with OpenDaylight, and so an SDN controller and VIRL. And then Valerie's going to talk a little bit about what you can expect at Cisco Live in San Diego, which is coming up in about 6 weeks' time. And then we'll try and finish up with Q&A. So as I said, do please try and keep the questions coming. The team's there. They're going to try and do their best to answer the questions as we go. All right, so the April release went out last Tuesday. Hopefully some of you have had a chance to take a look at it, have a chance to download it, install it, and start to work with it. But for those people who haven't had a chance, we wanted to just show you some of the highlights of it and then quickly do a live upgrade to show you, how this can be done. So we have a number of new virtual machines that are in here, an update to the iOS V. So previously we've had the 15.4.3M. We have a new image, 15.5.2T, so that's in there now. Very, very happy to provide availability at long last to the iOS V Layer 2 switch image. So this is our image that we demoed back in the February webinar. That's now available for you guys to use. We have an updated NXOS V. So this is from 7.10 that we had previously to 7.2.0, and this image includes the NX API toolkit, which for those people who attended last month's webinar, so the March one, the NXOS team showed us some of the capabilities of that image, so that's included there too. We also have, and I know a number of you already have it, the ASAv 932. So for those people who don't have the ASAv image themselves directly, that's now an image that you can pull down. That's going to be plugged straight into the rest of VIRL and has auto-config support. So we've got the basic configuration capabilities when you press that build initial config for ASAv and also for the iOS V L2. So all that functionality is now in place there. Some of the additional capabilities, GraphML, so another file format for both import and export. So if you're not familiar with GraphML, it is an open source file format. There are quite a number of groups who have used this or continue to use this. Tools such as YEd, which you may have come across, that's a fairly well-known and popular GraphML editor. And if you're interested, there's a large data set sitting there at this thing called Topology Zoo. There are approximately 260-odd network configuration files, topologies, that you can pull down, import in, and use those within VIRL. And there are some interesting ones from a range of different service providers around the world. Not necessarily the levels that you would expect to see in terms of configuration details, but they are primarily topology sets. So some interesting network topologies in there if you want to go and take a look at that. Also, it has the integrated packet capture, so this is the Wireshark kind of capability that we showed in the webinar last month, so that's all in there, as is the integrated capability to do interface up, down, and control that link state. So how can you do the upgrade? For existing users, there's the in-place upgrade. and there are two different forms of that, one called quick and one called full. So what's the difference between quick and full? Quick is doing just the in-place package upgrades for the VIRL core code and also the Auto Netkit engine, as well as adding in some patches which are required to enable the full layer 2 capabilities that we need. Whereas the full upgrade is actually doing upgrade of not only the VIRL core code, Auto Netkit, etc., but it's also doing a full update of the operating system, so taking Ubuntu 14.4.1 and bringing it up to 14.4.2. If you would prefer, we can make available the OVAs and ISO images, and the OVAs and ISO images are available as of today. So those images have been posted. The release is 09242. Okay, so that image has gone up today. So new users will be receiving the OVA and ISO. If you've just placed an order for it, that's what you're going to be receiving. If you've already got the 0917, you can, as I said, request an updated image and download that. And also, you will see on the discourse, the community forum, if you search for, and Ed's going to have to correct me if I'm wrong, if you search for the download service, there is a self-service location now and a salt command that you can use in order to be able to download the OVA or the ISO image directly. So you don't need to mail in, you can actually receive that directly. Okay, so we're going to show you now how we do that in-place upgrade. I'm going to demonstrate a quick upgrade. The full upgrade can take in the region of sort of 40 to 45 minutes because it's doing a full update of the operating system. So I'm just going to switch over to a couple of items here. So it's going to switch. One console. And then we want, and there's the other. Okay, so hopefully everybody can see. I've got an OVA here. So this is the VIRL 0917. So this is the same as you would have received, and you've got that up and running. First thing that we want to make sure before we actually do the upgrade is to make sure that we've actually got communication to our salt server. So we're going to issue the command here, salt call test.ping. So if you've got the system up and running and you've put in your license key, this is just validating that you've got communication and contact with that salt server. There are a couple of small changes that we need to make to the VIRL INI file. So you'll see in the upgrade instructions there are commands like this one, and also a script that you can run through. So you don't need to sit here and actually enter these commands manually. You can actually just run the script and it will take care of all it for you. What these commands are actually doing is making some modifications to this thing called the etc VIRL INI file that is turning on a support for the iOS VL2 and ASAv images so you can actually download those. So once those are done, we have to just enter what's known as the salt grain. So we run this command vinstall salt. That's loading up the salt grains, effectively turning on the settings. Next command we're running is the sudo vinstall. This is pulling down the latest update and install script. So that's what's running now. So that's just pulled in and that's complete. And that will then come back and return. Okay, so that's taken us about a minute or so to do. The next command that we're running now is we're going to pull in the VIRL STD package. So this is the VIRL core code. So this is approximately 19 megs worth of data plus an updated set of additional files. That's what's pulling in right now. You can see that scrolling through there. And this is pulling down all that new functionality. So this is the packet capture, the interface updates, modifications, a series of bug fixes, all the various elements that you've seen in the webinars in last month, and that's now going to pull in. Once that is installed, we're then going to pull in the Auto Netkit core code. There are some updates that we need to do to OpenStack itself because we're making some modifications to support the layer 2 switching functionality. Now, why do we need to do that? So remember that underneath OpenStack is a layer 2 switching operation, this thing called Linux Bridge. Linux Bridge operates, well, it's expecting everybody to be a end host or maybe even a router. What it's not expecting is to see other devices that are operating as layer 2 switches. And as a result, by default, it actually will filter various packets, things like spanning tree, for example, BPDUs. It's actually going to drop those on the floor because it's not expecting to see those things. So we've actually had to relax the filter rules that are normally in place in order to allow things like spanning tree, BPDUs, packets that are used for things like PAGP and LACP. So if you're into port channel configurations, you need to have those kinds of changes made to the filters that are applied to Linux Bridge in order for it to work. So there's a specific set of changes that we have to do to OpenStack to make that work at the Linux Bridge level, and some patches to the Linux Bridge code, and we'll show you how you do that. So that's the VIRL core code is almost in place now, and that process is just restarting. So there are those status messages executing right now. So we're doing the stop, and that's going to then do the start. And then we're going to follow this up in a moment with the next command, which is going to then bring down AutoNetKit. So that's UWM done. And we are almost done. So I'm talking at the moment to one of the EU, because I'm based in London, so I'm talking to one of the European servers. Obviously, you guys may be based in the US. You'll be talking to those servers. So that was the core code done. That took approximately 4 minutes or so to go through. So AutoNetKit is a much smaller package that'll run through a lot faster. Just let that one scroll through. And with the AutoNetKit, this is now pulling in the capabilities for layer 2 switch configuration, also the ASAv support, a couple of other fixes, patches, and things of that nature. So all of that is now coming down as we do this. So that's processing through quite nicely. Almost done. That's now wandering through. You can see the various changes that are happening as the packages are getting updated. And then we're going to do 2 more commands before we're ready to reboot. And then I do want to show you how you pull down, or how we can pull in the additional virtual machine images. So that's almost complete now. Just restarting some of the processes. There we go. So the process restart's taking place, so that state's now complete. Done. Okay, so now we move on to the next one. So this is now doing those patches to the OpenStack networking elements. This is the neutron function that we're doing here. And that results in a set of process restarts taking place as well. Almost done. And we're going to probably see one error message. Oh, no, a number of error messages that have come through. That's fine. We don't need to worry about those. If we scroll back up, we'll see some red errors. Yeah, that's all okay. Those can be ignored. And then we're running one last state, which is this vinstall bridge. This is the compiled Linux Bridge kernel patches, as I mentioned earlier, that relax the filtering and allow us to have normal packets that we would expect to see passing for layer 2 switch devices to go through. Now, one of the things that you can do, and we've actually posted this as well, is run a test topology. So we have a test topology that includes the use of LACP to confirm that that patch has actually taken place. Okay, so that's all done, and now we're rebooting. So that's taken approximately something like 10 minutes to complete. And the system at this point is now actually upgraded. We have all the latest code. The only things that are now missing are the new virtual machines. So I want to show you a couple of different things that you can do there. So that's just rebooting, and we're just going to turn on sharing a web browser. Sorry, one moment. Okay, so hopefully you should be able to see this panel. So I'm going to refresh that once my machine's back up and running. The key panel that I want to look at here is this VIRL software. So with the software upgraded, when we press the VIRL software, it's going to do a query to the SALT servers and see what new versions of code are actually available. So there are two sets of operations that you're going to need to perform. We have an updated version of the VIRL VM Maestro client UI. So that needs to be pulled down. So that's going to update you from VIRL Dev 128 to the new version. So it's 122 Dev 211. And also the new set of VIRL virtual machines that are available for installation. So it's up to you as to which sets of virtual machines you wish to pull in. So you may say, no, I'm quite happy with the sets of, so for example, my older IOSV instances, don't want to necessarily update those, but I do want to pull down like the ASAv. So it hasn't come up yet. Just kick that a few times. There we go. Okay, so we're going to now log in. Usual username and passwords, and here we can see we're now upgraded, so it's 010.14.20. And now it's going to query the backend servers, and it's going to list what new versions of code are available. There we go. Okay. So here we can see that there's now, this is the current version of code that I've got available, and here we can see that the available version, that there are new VM Maestro binaries. So I can set these flags here, say, yes, I would like to have, the Windows 32-bit or Windows 64, tick that and press the start installation. If we scroll further down, here we can now see the new versions of virtual machines. So here we can see ASA is available, IOSV L2 is available, NXOS, etc. So again, I can tick the various boxes, press start, and that's going to go ahead and do the download. So I'm just going to also show you a different way of doing that. So you can go in and you can run the command. So sudo salt call state.sls virl.router VMs, and if we want to put down the IOSVL2, it's IOSVL2, and let that run. So the web interface that we have here is doing the equivalent of running these commands that you see here. So that's now reaching out to the file server, grabbing the IOSVL2. That's then going to download. It's about just over 120 meg, something of that nature. So we're not going to sit here and wait for that to go through, but that will then pull down, and once that's actually installed, you'll see, obviously, that the available version, that value there, the 15.2.14.4.11 is going to appear on the left-hand side, and you will also see the IOSVL2 image pop up in the list of available images. So that's a very, very rapid walkthrough of the quick upgrade. There are full instructions, as I mentioned, posted. We've had good numbers of users who've been using that, and also there are the scripts for both the quick and full there, so you don't need to sit there typing the commands. You can literally just take the script, copy and paste, or run that script, and you're away. Okay. So with that, I'm going to hand over to Tom, who's going to take us through Do You Git? Tom, over to you.
Okay, we'll start with a couple of overview slides just to get everybody to some sort of level set here. So first, what is Git? It's a free open source distributed version control system. We're not going to explain exactly what all those words mean, but if you want more information, there's a gitscm.com is a good place to start. Git was originally developed by Linus Torvalds in 2005 to work on the Linux kernel. And he released it for everyone to use under the GPL v2. So Git is version control system. So it manages a set of files and the changes that are going on to those. So you can add and remove files. You can commit the current state of all your files to the repository. You can see what the current status is. You can see a log of changes over time. The main point for us is that it also facilitates sharing. You can pull changes from remote repositories and push them back. You can merge in changes that have happened during concurrent edits. So if you've used any other version control system, Git, it's a little bit different in its implementation, but similar sort of feature set as something like a CVS or SVN in terms of just revision controlling systems. So there are a couple different reasons to use Git with VIRL. One use case has come up a couple times on the forum. If you're using VM Maestro on multiple different machines, you can, maybe you have it on your workstation, but plus you want to use VM Maestro on your laptop when you're outside enjoying the weather. In those cases, you can, copy files back and forth between your machines or use Dropbox or something like that. It's from my perspective, usually a little safer to use something like Git. I work on my laptop. I'm done here for now, so I commit all those changes, push them back up to my shared repository, and then when I go sit down at my workstation, I can pull all the changes down there. Of course, another common use would be sharing topologies within a team. So if you're working at a company that has multiple VIRL users and you want to share topologies, this would be a good time to use Git to store topologies among the group so you don't accidentally lose changes or overwrite things, or if you find something weird in the configuration of one of the nodes, you can backtrack and figure out kind of where that came in and what you need to do about it to fix it. And then the thing that we'll be covering today is the VIRL open sample topologies. So this is another reason you might want to use Git. We're actually pushing some sample topologies that we're making available through GitHub on this project, VIRL open sample topologies, and we'll go through how to do that and do it integrated in with VM Maestro. So with Git, there's a repository. There can be multiple clones of that repository. When you clone the repository, you get a copy of all the files in your workspace plus the full history of that whole repository. These multiple repositories could be you and a bunch of your teammates. It could be just you, but it's on you on different machines. Let's see. So the very basic Git workflow for those who've never used it, once you will go and clone a repository, you now have a local copy of that repository. You can work locally, commit changes locally. You can also pull changes down from that remote repository. And if you have permissions, you can push changes back to the remote repository, to the upstream repository. So it would look something like this. If you have you and one other worker or you on two machines, you both end up cloning the same repository. And then, the green user here, maybe he adds a file, he makes a change, he adds a file, he commits that to his repository. And then he pushes that upstream to the upstream Git repository. That's now available for anyone who's cloned that one. So now the blue user can pull that down. He now has that new file on his local machine. And maybe he knows that there's a mistake there, so he modifies the config, makes some sort of change, and then he commits that locally in his own repository, and then he can also push that change up to the upstream Git repository, and now it's available for other users like the green user to pull that back down. So this is how Git works in a very simple case. We're not going to talk much about merging and branching, all that other fun stuff today, just sort of straightforward. I want to share some topologies and the simple cases of pushing up, pulling down. Like I said, we're kind of focused here today on the VIRL Open project. So that's actually a project on GitHub. So GitHub is a collaboration platform and web app. It's mainly for hosting projects. They do Git repository hosting. It's free to use. You can create an account if all of the repositories you're using are public. If you want private repositories with GitHub, you have to pay them. But for public open repositories, you can create an account and use GitHub for free. The VIRL team has created this project here, github.com/viralopen. We're using that to share some utility scripts and some sample topologies. We're also looking for contributions from the community. That means you. So if you have cool scripts of things you've done to help automate around VIRL or neat topologies that you'd like to share, you can submit a pull request through GitHub, and we will take a look and see if we can pull that into our repository. So all that's just basically about Git. Now you can use Git with VM Maestro without doing anything special. You can use Git entirely without VM Maestro. If you're using Git, just your own client or the command line, there's a few things that you need to do. You want to keep the Git repository sort of separate from the actual VM Maestro workspace. And then when you do operations in Git, you will probably have to go into VM Maestro and click that project and say refresh. That works fine, but for a more integrated experience, VM Maestro includes Git support directly. So you can clone repositories, you can pull and push changes straight in VM Maestro, and we're going to demo that in just a minute. So the first case is actually a fairly simple case. This is just the read-only case. We have the VIRL Open project out there. They're the sample topologies. If you just want to pull those down, have a copy locally so you can look at them, run them, just use that as reference, that's actually the simplest case, and you don't even need a GitHub account. You can just do this as an anonymous user. So we're going to do that first. Let me set up share. Also, okay, right. So here's, hopefully everyone can see this, the Safari browser here. So this is the project on GitHub. Again, like I said, it's github.com/virl/open. This project has a couple different Git repositories, but we're going to look at the sample topologies today. So the first thing we're going to do here is just clone that the URL that we're going to need to clone this repository. So there's a button right here. We can just click clone. That'll copy it to our clipboard. And now we go into VM Maestro. So the easiest place to get to here in VM Maestro to clone that repository is this button here up at the top for these perspectives. Click Open Perspective, select Git, then click OK. This will open the Git perspective, which has a Git repositories view. There's a few easy options here, so we just click the Clone a Git repository. It'll automatically pick up the URL straight from my clipboard, so that it's the correct URL to use. And like I said, this is a public repository, so I don't even need a username or password. I can just have it blank like that. We click Next. On this dialog, just make sure Master is selected. It should be auto-selected. And then on this dialog, you'll probably need to click this Import All Existing Projects after clone finishes. So it's going to clone, and then we're asking it, after you've done the clone, go ahead and pull a project of the sample topologies into my VM Maestro workspace. I click Finish. It's not a very big repository, so it clones very fast. You can see it here, but we really don't need to do much with this. So we're going to close this. Joel, you can go ahead and make that change now, if you would.
Okay,
so,
that's done, Tom.
Thank you. So we have, this new project now. I have my topologies, the standard sample topologies that comes with VM Maestro, but then there's now the one that comes from Git, and you can see this little, sample topologies master. It has kind of these weird orange icons here to indicate these are coming from a source control repository. So there's a bunch of different folders here with various topologies and description files in them. We've got like a unmanaged thing, L2 topology. I think we demoed this in the March webinar. There's this one from the current webinar, just this Git demo one. So you can open these up. You can look at the nodes, see their properties, see if they have configurations, and we'll use this to demo, various different, just provide examples of various different demo technologies or, specific routing protocol examples, BGP, OSPF, and we hope to expand this, set of topologies over time. So now I'm a user, like I said. It's just anonymous. I don't have any specific access or rights to this, but I can at any point say, okay, I've seen or heard that there are new changes up there, or I just want to check. I can come in here, right click and say pull, team pull. And that asks VM Maestro to pull changes down from the repository. So in this case, I'm going to pull down, this change that Joel just made. And this was to the Git demo file, Joel. Okay. And Joel actually broke the file, so we know that it was Joel's change. Yeah. Okay. And hopefully we will in the future not upload broken files for you guys to pull down.
Sorry.
All right. Okay, so that was just that version, and now we're going to look at a slightly different way of doing this. So we're going to go back to the slides for just a minute. Okay, so that was just, I've got my changes. I just want to have a local copy, read-only. I can look at them. I can even launch them if I have, the prerequisites to run them locally. I can pull down new changes as we publish new changes there. That works all fine. If you want to be able to make your own changes and check in those changes, or especially if you want to be able to propose changes to us, then there's a separate workflow that GitHub uses. It's common with Git. This one does require a GitHub account, so you'll need to create a GitHub account so that you can authenticate with it. And let me get something switching over here. Okay. So this will let you clone the repository, but you'll also be able to still pull changes from us, but you'll also be able to push changes up and then ask us to pull your changes into the sample topologies. So this one looks like this. On GitHub, we're going to fork that topology. Fork that repository. That's very easy. We'll show you how to do that. And then you're going to clone not the VIRL open copy, but your forked copy, and that will get you a local Git repository of those sample topologies. And then we're also going to add a remote connection to that original repository. So you'll have full sort of read-write access to your own forked copy, and you'll also be able to pull changes down from the VIRL open topology, from the VIRL open original repository. And when you fetch those down, you can, make those changes locally, merge them in, and push those to your own copy. But you can also add files or make changes and push those to your repository and then submit a pull request to our group. So we're going to run through that real quickly, and then that will be it for today's Git stuff. So let me just reshare VM Maestro here. And Git. Okay. So, okay. So this is actually a separate VM Maestro workspace for me. So we're going to do something similar where we say, I'm going to open that Git repository. But before we go try to clone that, we're going to come over here to GitHub. And you'll see on the GitHub VIRL open sample topologies, there's a fork button. So you can click this button, and basically on Git you'll have your own space. And when you've done a fork, you basically can see that you have I've already done this. So when you click this fork, you'll get a fork of the sample topologies, and it'll say it was forked from VIRL open sample topologies. But now this is my own copy on GitHub, so it's public. I can push changes up here. My friends can all come look at this one if they want. I can give them access to it. But it does, have its origins in the VIRL open sample topologies. So when I clone, I'm actually going to clone from this copy. Okay, so here we are, clone Git. Like I said, this is now, you see this is my tbryan314 account. This is not straight from the VIRL open account. And I'm going to set this to be 314. And if I can remember my password. All right. So now we're cloning. Like I said, we're cloning from this. Again, we do the import all. I already have a copy of this from the other account, so I give it a different location. But basically, same way all the way through. Make sure it says import projects, and there we go. So again, we clone the repository. If I go to the design view, I have a sample topologies project here. This came from Git now. But the other thing that I'm going to do to this particular repository is establish a remote connection. So here I'm going to say create remote. I'm just going to call this VIRL open. And we're going to configure this for fetching changes from there. And we go back to the, this is my own local copy, which I just cloned. I'm then going to say it was forked from VIRL open. So I'm going to go back to the VIRL open sample topologies, copy that, and then we're going to use that in this dialog, the VIRL open location. So this is basically setting up a separate link in this Git repository locally to say I'm also tied to this remote of VIRL open. So what does that do? So again, I have my I have the set of topologies here. I can pull these down. I can say I'd like to go to the remote system and fetch from just the VIRL open one. So this basically says, even though I've cloned from my local copy, I can fetch changes in anything that's going up to the remote one, and then pull those things in if I want. The standard procedure, if you're going to pull changes in from the remote, is to do that remote fetch and then do a merge locally to say I'd like to merge in the changes that came from VIRL open master and merge. So now I have the changes in. I just pulled in the April webinar files. So those actually came from that, like I said, the separate remote one. So I could do again, that was to pull the changes in from in this case, when you set it up as a fork, you do a fetch and specify your your VIRL open copy, and then after you fetch, you can do a merge and select that, the merge from the VIRL open master. So that'll pull in changes, even though you've got sort of a separate fork, that'll pull in changes from that repository to you. The other thing you can do here, and let's see, this is probably still broken. Yep. All right. So I'm going to actually look at this one and probably see if I can, well, let me just actually do a separate one. So the other thing that we can do here, like I said, is contribute topologies. So this is just a simple file. It doesn't really matter. We just want to show the workflow here. So I just have a very simple topology. It's kind of new here, so in general, I can commit that with Git. So this is I can enter a message if you're making specific changes, like committing, changing configurations, or oh, I'm switching this from OSPF to EIGRP. You put that commit message here so that people in the future can kind of figure out what changes you're making. I can commit that here. That just commits it locally. Once I've got the local changes that I want, I can then also push to upstream. So upstream is, my local copy. So now, or my GitHub copy, the fork. So now I pushed all these changes up to the fork. If I look at that forked repository on GitHub, Bryan, we can now see in this folder, webinars, we now have an April folder, and this is my Git demo 2 that I just pushed up. The other thing that you can do, and the reason that you want to do it this way, is if you're contributing through GitHub, the standard way to do it is to get to here and then say, I'd like to issue a pull request. You click this button to say create a pull request, and now it will show you what changes you have locally, or sorry, what changes you have in your fork that are not in the main Git repository. So I can say, hey, look, I've just created this cool topology file. it's showing me I've got just one commit that would need to be pushed over to the other one, over to the VIRL open. So I click this button to create a pull request. And if you need to explain kind of what that is, you can explain that here. You can carry on a conversation if we have questions about that. But when you create a pull request, the VIRL team gets notified, and we can now pull that change in from your fork. So this is a common way on GitHub to contribute to other people's repositories. You just fork their repository, you do whatever changes you want, you commit them to your own, like I said, your own fork of their copy. This is my own Bryan 314 fork. Once I commit them here, I can then go to this pull request button and then say, I'd like to submit this change that I've committed to my repository and have you pull it into yours. And then once it's in the VIRL open topology, if we accept that change or accept a new file, once it's in that VIRL open repository, everyone can get that just by pulling straight from that Git repository. So everybody who's cloned this can then pull down that change, and they'll have access to that file. All right. I think that is all for today. So again, the basic operation, if you just want to see it, it's very simple. It's just copy that URL, stick it in the clone Git, and then say import project one done, and you will have the project locally, and you can pull anytime you want to pull down changes. If you'd like to submit changes, if you've never used Git before, you can refer back to this webinar, but like I said, there are a few steps where you want to make sure you're synced up. You fetch from the remote to make sure you're kind of synced up to the latest, commit locally, push it up to your fork's copy, and then submit the pull request. And after that, I think we hand over to our video, Joel.
That's right. So we are joined remotely, so to speak, by Daniel Clark. Daniel's a Cisco engineer based out in Australia. He's got a video because he's fast asleep, or should be at this point in time, just showing how he is using VIRL on a day-to-day basis. So he's done a video recording for us. So Valerie, if you want to share the video, and hopefully the audio is going to come through with everybody.
Yep. Can everyone see my screen now?
Good to go.
Okay, let me play it.
Hello, everybody. My name's Clark. I'm a network consulting engineer with Cisco, and about a month and a half or so ago I caught up with some of the VIRL team at Cisco Live, and they asked me to record a quick video on how I use VIRL in my everyday work. So one of the most obvious use cases for VIRL is as an education platform. Build up topologies, implement protocols you may not have worked with, or implement features you may not have worked with. And that's a very valid use case and definitely something that you should do. But what I use it for mostly is more around testing, verification, verifying designs, what-if type scenarios, and that kind of thing. So this is a topology that I've been working with quite a lot recently. So it's basically a very small, miniaturized version of an MPLS network that I work on. I've got my 3 P routers, so my provider routers, 3 PE routers in different topologies, and then just a single CE off to the side. And I use just a single CE and carve it out into multiple VRFs to simulate multiple end hosts, so to terminate multiple customer circuits. The reason I use just a single CE is it's a little more economical in terms of CPU. So because I only need a basic host, I can use just the 1 VM. Takes it, reduces my node count and reduces the load on the CPU, that kind of thing. So predominantly what I use this topology for is automation testing. So I have some automation servers sitting out in the network, and then I use this topology to test provisioning scripts like activating a new customer circuit, or pushing an LSP around inside the core, modifying an LSP, and so on and so forth. So the P routers are, although the topology is significantly smaller than what we work with in real life, the P routers are configured much the same way as they would be in the production network. The PE routers are configured much the same way as they would be in the production network. So what I do is I bridge the flat network out to one of my P routers. So on the P router, it's just a regular IP interface. It has an address in the flat network, which is I think 172.16.1 something, and I just add that to my IGPs. So I advertise that range in my IGPs, and then these servers I've got sitting out here, I don't actually use the servers within VIRL itself. I've just got them here as indicative, but on the flat network, I have my automation servers. So on the same ESX that I host my VIRL server, I've got a few other servers sitting there as well. And they all have a patch into the flat network, and they get an address in the 172.16 space, and then I'll have full IP connectivity between my servers and my virtualized topology. So because most of this work is around testing configuration, like pushing configuration and verifications of pushing configuration to the devices, it lends itself quite well to virtualization because the configuration I would commit to a virtualized XR node or to a physical XR node is the same. So it's also handy. Most of the devices I work on day to day are XR based, and we don't always have access to large-scale XR topologies to develop and test against. So for this purpose, it's really quite handy. You can build your scripts, modify them, try out different ways of doing things, and once all of that is fairly well in concrete, you can start to look at moving to a physical lab or production. One of the other things we tend to do with VIRL is in this example, say you are tasked with migrating a device, so for whatever reason, hardware lifecycle, whatever it may be. So in this mock-up, I've got my 4 core devices, a couple of edge boxes, and then I'm implementing a new core device. So I'm migrating core 1 to core 1 new. So again, mostly on the control flow side of things, I use VIRL, so you cable it up, virtually cable it up, and you can think about how would I go about this migration process. How will I configure my IGPs? How will I introduce the device to the network? Will I swing BGP across? How will I swing BGP across? Will there be any policy modifications that need to be done? So in this environment, you can sort of step through that migration process before you ever get to the real network. And that's kind of nice because you can iron out any kinks. You might see halfway through your migration that you're routing in a direction that you didn't necessarily expect, or you've got a bad cost configured somewhere, and things don't necessarily flow to your expectation. So that's very valuable. Also, you can shut down links, shut down devices, have a look at what impact that would have on your topology, which is not necessarily a luxury you would get in production. So that's also quite a handy thing to work with. So how would you migrate between or migrate to a new device? You can go through that entire process and optimize it long before you get to the physical network. So I guess one of the last things that we use, I'll go back to my MPLS topology for this one. One of the last things we do with VIRL, and it's all, again, very much in the same vein, is you may have an existing network or a model of your existing network, and organically over time your network's grown and you want to go back and redesign IGP costing or whatever it may be. So you can use VIRL to build up the current state of the network. Then you can go off and do your design. How do you want your redesign to actually look? And then you can also implement that in your virtual topology and make sure that your design is solid. Make sure that when XYZ link fails, everything gracefully moves somewhere else, or your routing paths, you've got redundancy and so on and so forth. So that's really quite a handy thing to do. So again, you can map out your entire design, test everything, and know well in advance before you go into any sort of physical testing or production environment that overall the concept is sound. So hopefully that gives you a bit of an idea of what you can do with VIRL above and beyond just an educational tool, and how you could potentially use it as part of your day-to-day operations. I hope that's been informative, and thank you.
Okay, so thanks obviously to Daniel for doing that, and hopefully that gives people, again, just a taste as to some of the things that you can actually do with the VIRL system. Okay, so we're going to skip along. Whoops, too many slides. Come back. There we go. Right. Okay, conscious obviously of people's time, we are running a little bit behind schedule. We promised that we were going to take a look at OpenDaylight and VIRL. I'm not sure how many people are familiar with OpenDaylight, but this is an SDN controller. It's an open source project with contributions from Cisco and a number of other vendors as well. More information, take a look at opendaylight.org. The software is there and available, and also some pretty good installation and deployment and development guides sitting there. So what we're going to do, we're going to show you in this demo, is I've got ODL installed on top of a Linux server with the appropriate packages installed. It requires JavaScript to be installed, but you can then go and download the available packages from the ODL environment. ODL has a number of different what they call plugins or features, and that includes things like OpenFlow controller, netconf, resconf, BGP, PCP, BGP-LS support, and a range of others. Now, unfortunately, and I know a lot of people ask questions about this, unfortunately, we do not have today a Cisco switch virtual machine that actually supports OpenFlow switching. However, you can get OpenFlow-enabled virtual machines such as OpenVSwitch and have that working in conjunction with an OpenDaylight controller. But what you can do, and what is available within the range of virtual machines that we have in VIRL today, is you can have the ODL SDN controller talking to iOS XRV virtual machines. And those will then use a range of MPLS-TE, a function called PCE, BGP-LS, to then be able to run MPLS-TE tunnels, create those tunnels, control the paths, send traffic across different paths, and provides an environment where you can start to experiment with what you can do with this kind of controller technology. Another key capability within it is both netconf and resconf, so a programmatic mechanism by which you can query, in this case the XRV devices, and extract information on a range of different topics. For those people who've come across it, the NCS platform can also plug in and run alongside OpenDaylight. But we're not going to show that bit here. We're actually just going to show this particular environment. So what I've done, like Daniel just described in his video, is I've got two separate simulations that are actually running. One in which I've actually got my OpenDaylight controller, so that's the one on the left, and the other where I've got my iOS XRV instances. And we're using, again, the flat connector to provide connectivity between the simulation, the simulation itself, so the XRV instances, and the OpenDaylight controller. So these two systems can actually see each other via the flat network. And we'll go some more into some of the properties that we're doing in here. Because we're running inside of VIRL with both the controller and the simulation, we can prep the system with static IP addresses. So the systems on each side know where the other one actually is. Remember, of course, that you might have a controller that's sitting on a completely different physical box. Again, using the flat network connector, that could be a real device sitting somewhere, could be a virtual machine running in a different location. All of these things are completely possible. But we do need to provide connectivity between the controller. So here we've actually got a Linux route add entry that's going in to provide connectivity, in this case, to the loopback IP addresses of our XRV devices. So those are sitting in the 192.168.0/0/24 network. Okay, so I'm going to switch over and show you this in action. So if you give me a moment, we're just going to share VM Maestro and also going to share the ODL desktop as well. So that should come up. There we go. And oops, I want to share. Okay, so here we go. So as I said, two different topologies that we have running. So here is our test topology. So we've got the various devices, the XRV devices. Now, in this particular case, we've actually posted this topology so you can see this. This is available in the GitHub repo that Tom showed us earlier. So we're setting various parameters on these devices. So if I take a look at the XRV instance that's here, in AutoNetKit, under this AutoNetKit tab, with the new VM Maestro that comes with the April release, you will see a new parameter, so ODL management group. So all of the XRV instances that are running in this environment are set up with ODL management group. Because we're doing BGP LS and PCE, we have to have ISIS enabled. That's the only routing protocol that works with the BGP LS and PCEP. And in addition, this device is set up as a BGP route reflector. To these devices, they are route reflector clients. There's another parameter that we've set here, so we can see this in a moment. So we've selected this device. So in this instance, this external router actually represents the ODL server that's sitting out across the flat network. Now, why have we got this thing here? Because we can attach parameters to it. So hopefully you can see down here at the bottom, there's this additional parameter that appears, external ODL. So I can feed in the IP address of that ODL server. Why? So when we run this configuration, when we pass this to AutoNetKit, each one of these devices will then be configured to talk to that ODL server. So if I run that through AutoNetKit, which I've actually done a moment ago, that's actually going to result in the appropriate topology being generated. And when we take a look here, we will get a view like so. So that's then representing, that's our ODL server that's sitting outside. And when we do the drop down, we can now see some additional elements that appear. So if we take a look at PCE, it's now showing that there is a path control element session running from our ODL server set up to talk to each one of the iOS XR devices. If we take a look at BGP LS, BGP LS is only running, so this is BGP carrying link state information, so ISIS information being carried and sent up to the ODL server. So we can see that session's there, and as I mentioned, we've got regular BGP taking place, so we can see again route reflector clients. Okay, so when we take a look, what is this actually doing? We're just going to take a look on the ODL server itself. So once you install ODL, it has an interface something called Deluxe. So that comes up, and then you can log into that. And there are a number of different elements. Depending on the feature set that you install, this panel on the side will actually extend. It's not great in terms of its actual topology visualization. There's still a number of applications out there you can download for free, plug those in, and enable them. However, what I do want to be able to show you is using some of the REST-conf functionality. So using a REST call, so this is just a web call, so you can see this here, HTTP, we're querying port 8081 on the ODL server using this REST-conf operational, so it's actually querying the database on the ODL server, and that is then populated with information that are coming up from the XRV instances. So if we run this query, we get a result that comes back. We see information at the top here, which is actually from the controller itself, but if I'm just going to fold that up, here we can see, here's the iOS XRV1. So this is a query that just took place using netconf over the REST-conf interface to actually pull information out of the iOS XRV instances. So this is repeated for each one of those XRV instances that's present, so we can see data that's actually being returned from it. This is more about the Yang models that are present on the system itself. We'll do a different query. So if we say, right, show me the network topology, again, this is now pulling link state information. So in this case, ISIS, we can see it here, ISIS information that's been transported over BGP, and this then gives us information about all of the topology that's present. So in this case, our set of 4 iOS XRV instances, full mesh, so you can then query through this REST return to pull out the various pieces of information that you may be interested in. Just one other one I want to show you, which is configuration. Here we go. So here we can see, again, a query. It's actually pulling configuration data, so we can see there it is. There's the XR interface on that particular node, so we can see the description, the IP address that's assigned to it. You've got the various other interfaces and their associated IP addresses. So you've got a programmatic way of being able to query devices in your network and extract information out without having to use complex, parsers or various other systems. So yes, you can do things like this using SNMP, but certainly RESTconf, NetConf, there's a lot of development, a lot of additional work that's going on in this area. ODL is just one of the tools that's available in this environment. So again, just a demonstration of some of the things that you can do. In this case, we happen to be showing, an OpenDaylight controller in conjunction with a bunch of iOS XRV instances. Okay, Valerie, over to you.
Hi, okay, let me grab the ball so I can share the slides. Here we go. Hi, everyone, this is Valerie from the VIRL team. So we just wanted to make a quick announcement about VIRL's presence at Cisco Live San Diego that's coming up in June. As many of you know, Cisco Live is one of the biggest events for IT professionals to learn about interesting products, tools, and get education and training for their careers. VIRL is having a big presence this year at Cisco Live, and here is a quick rundown of our schedule. So if you're going to Cisco Live, you know where to find us. VIRL will be having, the main location will be in DevNet Zone. We will have a dedicated VIRL booth as well as be in the DevNet Learning Labs area throughout the week of the event, which is June 7th through 11th. There is a 4-hour tutorial on Sunday 1 to 5 that will be given by Joe, Ralph Smita, and Bryan Doherty. And we have a VIRL session in the DevNet Theater Monday at 11 a.m. On Tuesday, we'll be having VIRL mini workshops from 10:30 to 3:30. The workshops will be in an intimate setting with 1 instructor to 4 or 5 attendees. We will post the full schedule on our community support forum, so if you're going to Cisco Live, make sure to drop by and say hi. There's lots to do, and we are having some pretty neat giveaways. And even more importantly, we are having our first ever VIRL user meetup during the week of Cisco Live. We will be hosting it on June 9th, Tuesday night from 5:30 to 7 p.m. in the DevNet Zone. So the idea is for you guys to meet the VIRL developer team, and we will break into discussion groups based on different topics. Our developers will be very interested to learn about what you're doing with VIRL and hear some of the feedback you have on the product. So we have a sign-up link here in the slides, but we also post it to our community forum as well as our social media platforms. So make sure to RSVP if you want to come so we know how many people to expect. And please spread the word to your friends and colleagues and even followers if you have any on Twitter. With that, Joe, I'll hand it over to you for additional comments and then go into Q&A.
All right. So thanks, Valerie. Certainly the sign-up link, it's not a case of, oh, I didn't sign up, I must not come. It's just to give us a sense as to how many people we're likely to expect. Obviously, bring your friends. Tell them how wonderful VIRL is. But yeah, as you said, it's going to be a chance to meet the team. We are as interested in what you find things that are working, also what you would like VIRL to be doing in the future, where you would like the product to go. So this is certainly your chance to talk to the guys, talk to everybody on the team. What's good, what's bad, what can we do better? Okay, we are running about 5 minutes over, and I know we've got people who are having to drop off. Ed, Ralph, Tom, particular questions, anything that you want to highlight that people are pulling up? And is there sort of 2 or 3 things that people are posting questions on that we can try and answer perhaps?
The only thing that I would like to mention is that, all the VMs that are running within firewall, I mean, all of this is pretty much without the influence from, or the limited influence from us, what we can bring on firewall and whatnot. So if it runs on KVM and if there is like some demo version, it probably can be made running on firewall, but it's not the firewall team that makes decisions on, what is available within the platform and what is not, because that came up, quite frequently.
Yeah. I just would like to highlight, while we've got the chance, if people are signing up on Discourse and are looking around on Discourse, there's actually quite a lot of activity going on. I just want to highlight this on third-party virtual machines that are out there. So we have people who've managed to get things like Juniper VSRX, VMX, Windows. We've got some guys who've managed to get things like the A10 firewall, Palo Alto systems integrated as well. So we can't provide the virtual machine images. That you will have to provide yourselves, but certainly, integration and getting that running in VIRL, yeah, we can do that. And then as you've seen, there are other people out there who are doing this and are coming up with multi-vendor topologies with all these various elements working. Routers, switches, firewalls, other appliances that can certainly be plugged in. Okay.
I was just going to mention, several people asked, we do post the webinar slides, the Q&A, and the recording. The recording goes to our Cisco VIRL YouTube channel, and the slides and Q&A will be posted up in a post at the community forum probably later this week.
Okay, thank you. All right. Ladies, gentlemen, our apologies. We've run about 10 minutes over. I appreciate people hanging on for the call. Again, comments, feedback, we'd love to get your thoughts on this, particularly in respect to videos that you'd like to see us produce. We have got videos posted up on YouTube. If there are particular topics that you'd like to see covered, please do let us know. We'll try and do our best to accommodate that. Can't promise that we'll get to them quickly, but we will try and do our best to get those there. Additionally, future webinar sessions. I know that there were some people who were asking Ed about sessions on SALT. If that's something that would be interesting, we may set something up specifically to try and cover that topic. But please, comments, feedback, we welcome those. Let us know what we can be trying to cover and how we can make these sessions useful and valuable to you. And with that, I'd like to thank you all for your time. And we will hopefully see you next month on the next call. And we're looking forward to meeting people up at Cisco Live in San Diego. Thanks very much, everyone.